Hi there and welcome to another video from HEGARTYMATHS. It's Mr. Hegarty here, and in this video, which is a Maths A-level video, we're going to be talking about integration and in particular integrating trigonometric functions using the trig identities. So in this video, the main thing I want us to be able to do is integrate some trigonometric functions using the trig identities and the standard results we've already identified in videos 1 and 2 in integration. Now here were the standard results, so it's quite a lot we've generated as standard so far. I'm dealing with trig in this video, so in particular anything within this section here. So these are what I call the standard results, the results you should be familiar with. They're either in the formula booklet or you should learn them. So all of these integrals here, anything in here should be something you should be familiar with. So I may want to rearrange a trigonometric integral that I have to integrate to something like this in order that I can integrate it. And these are the standard trigonometric identities I may use to do that. Now these two here, you should know these, but they come from the cos squared x plus sine squared x is identical to 1 from core 1 and core 2. So you should know that. These here are called the double angle formulae, and you should memorize them. And these here are called the half angle formulae, and you should know how to generate them, but you don't need to remember them. They're in the formula booklet, hence I've copied this off the formula booklet. So the half angle formulae. So what we're going to do, let's just think about what this might be about. What do I know here to integrate? Well, I know how to integrate sec squared. Because I know tan differentiates to sec squared, I know that sec squared integrates to tan. So say if I was given something that involved a tan squared to integrate, I could rewrite tan squared in terms of sec squared because I know how to integrate that. I also know how to integrate cosec squared. So if I was asked to integrate something that had a cot squared in it, I don't know how to integrate that. I could rewrite that in terms of cosec squared, and then I'd be able to integrate it. Now, I also know how to integrate something of the form cos ax plus b, or cos 2x. So I know how to integrate that. So if someone gave me something that had a cos squared in it and asked me to integrate that, I could rewrite that in terms of cos 2x, and then I could get the answer. Similarly, if someone gave me something in terms of sine squared and told me to integrate that, I could use the result for cos of 2x and rewrite sine squared in terms of this and integrate that. If someone asked me to integrate something like 2 sine of x cos x, or as long as the angles are the same here, I would be able to integrate that by using the double angle formula for sine 2x. And similarly, some combinations of if someone asked me to integrate a sine of something was of this form, I could rewrite it in that form and then integrate it. Now it's all in the air now, it's all theory. It's best if I show you via examples how to do this, but the big idea is the following. We want to only be able to use these identities, and we're going to those integrals, and we're going to use these identities to be able to do that. So let's have a go at the first example. The integral of tan squared x. Now, the first thing you should be thinking, this is just in your thoughts, don't know how to integrate tan squared, don't know the integral of tan squared x dx. We don't know that, i.e. it's not a standard result. Now, at this stage, we don't know any other integration techniques, but I do know an identity with tan squared in it. I know that 1 plus tan squared of x is identical to sec squared of x. So tan squared of x, I could rewrite that as sec squared of x subtract 1. Now why is that helpful? Well, I'm asked to integrate tan squared of x with respect to x, and I could replace the tan squared with sec squared take away 1. So I could integrate instead sec squared x take away 1, all with respect to x. Now why is that good? Well, it's really good because I know how to integrate sec squared, it's tan. I know how to integrate 1, it's x. So I know how to integrate both of these things, whereas I know how to integrate that and that, whereas I didn't know how to integrate that. So I can break this up into the integral of a sec squared x with respect to x, take away the integral of 1 with respect to x. And the integral of sec squared, well, it's tan x, it's one of the standard results, so this is tan x. The integral of 1 is just x, so I'd have subtract x, and don't forget your constant of integration plus c. So the integral of tan squared x with respect to x is this here. Let's recap how I did this. I didn't know this, it's not a standard result. I used the identity 1 plus tan squared is sec squared and rewrote tan squared as the subject. So tan squared was sec squared take away 1. I replaced the integrand with sec squared take away 1. Because I can integrate sec squared, I can integrate 1, I can integrate the whole thing, and I've done the question. Okay, let's have a go at another one. The integral of sine squared x with respect to x. First thoughts are as follows. The first thing I want you to think is, well, the integral of sine squared x with respect to x is not a standard result. I'm going to put SR, is not a standard result. So I'm going to try and use an identity. Okay, I'm going to try and use an identity. Now, the identity I know, the best identity I know with sine squared in it, is the double angle formula. And I know that cosine of 2x is 1 subtract 2 sine squared of single x. So making sine squared the subject, I'm going to make sine squared the subject. 2 sine squared of single x must be 1 subtract cosine of 2x. So sine squared of single x must be a half 1 subtract cosine of 2x. Or I could rewrite this as a half subtract a half cosine of 2x. That's probably easier. Okay, so sine squared x as the subject of the formula is this. Now, the question has asked me to integrate sine squared x with respect to x. I didn't know how to do that, but I do know how to integrate a half, and I do know how to integrate a half cosine 2x, okay, because they're standard results. So I could instead write this as the integral of a half. I'm going to break this up straight away with respect to x, subtract the integral of a half cosine 2x with respect to x. And what I'm actually going to do here, I always do this with a constant. I'm going to take the half out, and that's a half the integral of 1 with respect to x, subtract a half the integral of cosine 2x with respect to x. Okay, well, what's the integral of 1? Well, it's x. So this would give me a half x. And subtract the half, keep the half there. What's the integral of cosine 2x? Well, the integral of cosine 2x is a half sine 2x. Okay, so that would be a half sine 2x. Like that, okay? And then don't forget your plus constant. So overall, the answer would be a half x subtract a quarter sine 2x plus constant. And let's just recap how I actually did this. Going up here, I didn't know how to integrate sine squared x, okay, no good. Instead, I realised that I could use the double angle formula to rewrite sine squared in terms of a cosine of 2x, which I can integrate. So I broke it into a half, subtract a half cosine 2x. I integrated both of those separately, and I got my final result. So the integral of a sine squared single x with respect to x is a half x subtract a quarter sine 2x plus constant. Okay, now you're getting the idea. Let's have a go at another one. Do I know how to integrate sine of 3x cosine of 3x? Is it a standard result? The answer is no. It's not a standard result, so not a standard result. So let's think, can I use identities? Now, the key thing here is that this 3x and this 3x are the same. That's very important when they're doing these ones. Now, you should know that sine of 2x, the double angle formula for sine x is sine of single x, cos of single x, and multiplied by 2. Now, what this means is sine of this angle here is 2 sine of half the angle and half the angle here. Okay, so in particular, if I had, let's say, sine of 6x, that would be 2 sine of 3x cosine of 3x. This angle is always double these angles. Okay, Now, can you see how I could replace this instead by something simpler? Well, I'm asked to integrate sine of 3x cosine of 3x, and I'm thinking to myself, why don't I use the double angle sine formula and instead integrate a half sine of 6x with respect to x? The reason that is sine 6x is 2 sine 3x cosine 3x, so a half sine 6x must be 1 sine 3x cosine 3x. Okay? So, I can actually integrate this thing. This is an easy integral for me. So if I integrate that, I'm going to actually bring the half out and I'm going to integrate sine 6x with respect to x. Now the integral of this, keep the half where it is, the integral of sine 6x, well, it's going to have a cosine 6x, it's going to be a negative, and you're going to divide by the 6. So it's going to be negative a 6 and plus c. So overall you get negative a 12th cosine of 6x plus c. So let's just rethink how I got that. I saw sine 3x, cosine 3x, the angles were the same, that was very important. I used the double angle sine formula, which is the thing that most resembled that, and I knew it came from a half sine 6x, so I integrated the half sine 6x instead, which I can integrate, and hence I got the answer. Okay, let's have a go at this one. The integral of sec x plus tan x all squared. Now, is that something I know how to integrate as such? No. So there's no identities for sec and tan as such. There are identities that have sec squared and tan squared. So my obvious first step is just to go ahead and expand this. Remember, this is the integral of sec x plus tan x multiplied by sec x plus tan x. So the best idea to do here would be just to expand this integral. So that's the integral of sec squared x plus 2 sec x tan x plus tan squared x with respect to x. Okay, now, do I know any identities with sec squared plus tan squared? Well, I know that 1 plus tan squared x is equal to sec squared x. Now, I don't know how to integrate tan squared, but I certainly can replace it with some form of sec squared. So tan squared x is sec squared x, take away 1. So I could replace this with this instead. Now, do I know how to integrate sec x tan x? Yes, I do. Sec x tan x is a standard integral. I know sec differentiates to sec x tan x, so sec x tan x must integrate to sec. And I also know how to integrate sec squared. It's got a tan in it. So I'm going to replace this. I'm going to say this is therefore the integral of sec squared x plus 2 sec x tan x plus sec squared x take away 1, all with respect to x. And I'm going to combine that, so that's the integral of 2 sec squared x, there's 2 sec squareds, plus 2 sec x tan x take away 1, all with respect to x. I'm going to break this integral up, so I'm going to say it's 2 multiplied by the integral of sec squared x with respect to x, plus 2 multiplied by the integral of sec x tan x with respect to x, subtract 1, the integral of 1, all with respect to x. So each of these I'm going to show like that. Now, I know the integral of sec squared is tan, so this is 2 tan of single x. I know the integral of sec x tan x is sec x, so this would be plus 2 sec x. And I know the integral of 1 is x, so this would be subtract x, and don't forget to add your constant of integration plus c here. Okay, and so it's at this point we have the answer 2 tan x plus 2 sec x subtract x plus constant. Okay, and the last one here, the integral of sine 3x cosine 2x. Now, it reminds me a little bit of the one we did before here, but in this case the x's were the same, so I could use the double angle formula. Here, the number of x's are different, the angles are different. It's got a 3x and a 2x. Now, I want to show you, whenever you see that, I want you to think half angle formulae. Go to the front of your formula booklet and have a look at these here and see if there's any way you could link these to this. Now, the one that's most similar, you've got a sine of some x's and a cosine of some x's. So you want a sine and a cosine, and you get that in this case here. So we want to use the identity that 2 sine of a plus b over 2 cosine a subtract b over 2 is equal to sine of a plus sine of b. Now, can you think of what the a and the b have to be here in order to get 3x? Well, if you said I want a plus b over 2 to equal 3x, and I want a subtract b over 2 to equal the 2x, let's solve these simultaneous equations to find what a and b would need to be. This would mean that a plus b would have to be equal to 6x, and here a take away b would have to equal 4x. You've got two simultaneous equations. If you added them together, so if you added 1 and 2, you would get that 2a must be equal to 10x, so a must be equal to 5x. And if you've got a is equal to 5x, I think it's pretty obvious that b would be equal to, would do the trick for you, because then a plus b would be 6x and a take away b would be 4x. So let's see if we can write something down with this identity. 2, a plus b over 2 would be the sine 3x, cosine a take away b over 2 would be the 2x. This is the same thing as sine of single x, which is 5x, plus sine of a b, which is that. So I'm using this identity here with my a and my b found. So therefore, sine, without the 2, sine of 3x, cosine of 2x would be a half of this. So it would be a half sine 5x plus a half sine single x. Right, so instead of integrating this thing, if I want to integrate sine of 3x cosine of 2x with respect to x, instead I could integrate, and I'm going to do it all in one move, a half sine of 5x with respect to x plus a half the integral of sine x with respect to x. And I can integrate these things. So a half, this integrates to a negative a fifth cosine of 5x. And this, you've got a half here, and this would integrate to negative a half, sorry, not negative a half, sorry, it would just integrate to negative cosine of x, and you'd have plus c. So overall, the answer when I simplify it would be negative a tenth cosine of 5x, subtract a half cosine of single x plus your constant of integration, and we'd be done there. So let's just think, when I saw that a sine and a cos together, and because they're not the same angle, I think half angle formulae. I look at the half angle formulae, I see which one has a sine and a cosine, it's this one. I write down, I want my a plus b over 2 to be equal to the 3x, I want my a subtract b over 2 to equal 2x, I find the a and b I need, and then I use the identity with the a and the b found to replace this with some form of a sine a plus a sine b. And then I can integrate each part, I do the integration, and I'm done. So that's it for this section here. Just to make sure you understand that, go away and do the following work at the end and make sure you can do this on your own. Thanks for watching.